So today we're looking at factoring when the A value is greater than 1. That means there's something in front of it. We will put the A value on the top of the sides. After we find the factors, the sides will look like fractions, and we will work on reducing those fractions. Please make sure you guys are getting these notes down. So you guys have seen fractions before. The sides are going to look like fractions on your snowflake. We are just going to reduce that. In doing that, that actually takes out the hardest part of doing this factoring if we're not using this organizational method. So if we're not using this organizational method, because that A value is greater than 1, it really adds a lot more thinking and a lot more guessing and checking. But the snowflake really helps reduce that. So please make sure you get that down. Again, it might make a little more sense in action, but just get it down for right now. The other nice part here is just because of all the calculators and tools we're using. I know some of you might say, Mr. Oskov, I don't like fractions. Reducing them has been tough for me in the past. That's okay. While that is a skill we hope we all have at this point, I will show you how we can use Desmos to make sure we reduce a fraction correctly. It's actually pretty easy. Yeah, so negative 7x plus 4x, negative 3x. And then minus 28, and put that in, it should match up.
Minus 20.
Minus 28, because that's at the end, right? Oh, I was already starting to
Negative
count.
7 plus 4.
That's negative 3x, right? So that gives out to that square.
That's negative. Oh,
Yeah, negative 7 plus 4 gives me negative 3. So x squared minus 3x minus 1.
so that's square minus 4.
No. You'll see some pencils writing, not a big deal. Give you the time to get this down, and we got 4 examples with this.
Can you say? Control U.
Control 6.
It's still the first slide, right?
Yeah.
Oh, okay.
Or sorry, not control, shift. My bad. Yeah. Shift 6. Okay, let's take a look at this in action. Now, there are some slight changes to the snowflake method because A is greater than 1. So please make sure you're paying attention so you don't miss those very subtle and slight changes. Because if you miss them, it's going to make life more complicated. Hey, Miss Wright. Yeah, he was giving another student the middle finger, then told me to mind my business when I told him to stop. So honestly, well, he told me to mind my own business. So oh yeah, he has all his work to do. Yep. No, he didn't bring his laptop in here today. Yep, no problem. Oh yeah, good morning. Have a good one. So when I start this off, for here, you're gonna have to multiply. The number in front of the number and back multiply to the top number. If you do not multiply these together, things aren't going to work out how you need them to. So please make sure you are always multiplying these two numbers together. So 2 times -3, -6. Since there is a 2 up front, I put a 2 here and a 2 over here. Then finally, there's no number in front of this x, that means a 1 on the bottom. So now I ask myself, what multiplies to give me 6? So what pairs do I have for 6?
6 times 1.
6 times 1, 2 times 3.
2 times 3.
It doesn't matter what order we say them in. I usually like to write the smaller one first, but that's just me.
Can you do 3 minus 2?
3 minus 2 gets me 1. So this is the exact same logic here. It was just I need to make sure this number was right. So Jonathan's absolutely right. If I do 3 minus 2, that multiplies to give me -6 and adds to give me -1. So 3 and -2. Now here is where we have another wrinkle, a little wrinkle in this. Again, our logic hasn't changed, our ideas haven't changed. However, these look like fractions on the side, right? And we're going to try and reduce fractions. I know when a fraction has a 1 in it, things can't reduce really. But over here, we'll look. With 2/3, is that a fraction we can reduce? 2 over 3? No, that's already reduced. But what about 2 over -2? Which is, I've always heard somebody say it over here. This will reduce to 1 over -1. Now, if you're having trouble, like, oh, I'm not good at reducing fractions, why do we have to do this? Look, let's use Desmos to help us out here. Come on. There we go. So, calculator. So I'm going to start with 2 over 3. When it has this little fraction, bless you. In Desmos, we can click that and it makes it a fraction. So 2/3 stayed 2/3. So that told me, hey, that can't reduce. It is already reduced as far as it can go. Now the other one, 2/-2. That reduced to -1. So when reduced to -1, I know, oh, both those go to 1, but the one that was negative, keep the sign with that. Does that make sense right there? Again, we'll see this 3 more times. Now it's a matter of just writing our answer. See how there's still a 2 up here? We're going to start writing that one with a 2x plus 3. And then this would just be x minus 1. Now here with this, I could very quickly do FOIL to check that. So let's see, this will be 2x squared. My outer would be -2x. My inner would be plus 3x. And then my last would be -3. When I combine those, that gives me 2x squared plus x minus 3. That was the original equation, right? So this was just a check using FOIL. Remember, we can also check using Desmos by graphing both equations. I'll check it that way for the rest of them. But here we just did a FOIL check, and there we go. Yeah. So guys, make sure you're getting this down. I'm not saying this is like super easy. Once you get used to this process is going to make more and more sense. Yep. Oh, then it was an error. I just like said, oh, those are my like terms combined. So right here it's just saying, hey, these two go together. So not going to say like, oh, I showed you this. This is going to be a cakewalk from here. It's going to take a second to figure out and get used to, but your practice with factoring and utilizing the snowflake method on the previous practice will be a big help. Good morning, Diane. You're just in our notes, okay? Yep.
I can get the -3.
3 times -1. That was just doing my last in the FOIL. 3 and -1.
Oh, yeah.
So let's look at example 2. Example 2, again, the numbers are getting a little bigger here, but we'll handle them. Again, I start with multiplying the front and back numbers together for the top of my snowflake. Again, that is a very critical step here. 3 times -8, -24. 3 up top, 3 up top, -2 on the bottom. So let's see, what multiplies to give me 24? Let's start with the easy one. 1 times 24, what else?
like the -8.
When there's a number in front, we have to do the number in front times the number in the back for up here. So that's that slight wrinkle I was talking about. It's not hugely different than what we were doing. Because this number's in front, we have to multiply the front and back. What else multiplies to give me 24? 2 and 12? Oh, I know 3 and 8, we just did that, right? What else? 4 times 6. And that is all our combinations. What combination can make that 2 for me? 4 and 6. If it needs to be negative, I make the 6 negative and the 4 positive. So now I go to C. Can I reduce fractions here? 3 over -6, can that reduce?
-2.
Yeah, that can reduce to 1 and -2, yeah. They're both divisible by 3, so that's 1 and -2. 3 over 4, can that reduce? No. So again, if you're having trouble with that reducing piece, you can utilize Desmos to help us out. Again, 3 over -6. There we go. That's -1/2. It shows up as a decimal. Again, just click this little fraction right next to it. But 3 over 4, we'll see when we click that little fraction, it says 3 over 4. So now in writing this becomes 1, or sorry, since it's a 1 up there, I don't need to write it. X minus 2. This still has a 3 up here, so that's 3x plus 4. So that's how we write the answer. Again, we could use FOIL to check it, or I really like the visual way of checking. Yes. Oh, I already had to pass out. So let's look at that visual way of checking again. Good morning. I'll grab your pen. Oh, thank you very much. Okay. So again, I had 3x squared minus 2x minus 8. So there's my original graph. And then the other graph I had, I said, oh, x minus 2, then 3x plus 4. And again, I get these graphs here matching this purple and green or the exact same graph. So I know I did this correctly. Again, if I had accidentally messed up and reduced it and said that was a 3, we see that purple graph goes off, but we had it all right. So we are good. Any questions so far on this? I know we're starting to with
So we
some.
always- I'm sorry, I mean, so we always want to divide times the number before in front and the number back.
Yes, yes, and that was the point of clarification we made earlier. I like re-clarifying that because that is the one small difference from what we were doing. That and the reducing fractions, those are the two big differences from what we were doing Friday and yesterday. So thank you for that. Yes, yes, you are absolutely correct. Let's take a look at 2 more examples. Again, we want to stress that multiplying by the back and the front together. Look, if I was doing this a more traditional way, I'd be like, oh, what can multiply to 8? Like, I know that could get like set up as like a 4x and like a 2x. Or I could set it up as like an X and an 8X, and then I start messing with 15. That way it gets really messy here. I have a lot of guessing and checking to do. But we're just going to do it this way. Now, 8 times 15 is going to give us a pretty big number. And we're probably going to have to check a lot here, and that's okay. So 8 times 15 is negative 120. Whoa. Big number. I'll talk about how we can work on that. 8 and 8, negative 14. So 120. Let's just go through this little by little. 1 times 120 works, right? Now, let's see, 120, that seems like it should be divisible by 2, right? So what would that be? 2 times what? 2 times 16. Okay, I look, 60 would be divisible by like 3. So that tells me, 3 is probably going to work on this. 3 times what gives me 120? 3 times 40. Okay. I look at this number 40. 40 is divisible by 4, right? So what would 120 divided by 4 be? 30. So 4 times 30. Okay. Again, looking at some smaller numbers here. I think 5 should go into it because 5 goes into 30. It should also go into 120. 120 also adds a 0. So that tells me 5 will work. 5 times what gives me 120? 5 times 24. Good. Okay. 6 goes into 60, 30, and 24. So 6 should go into this. What's 120 divided by 6? 6 times 20. Now, when I look at any of these numbers here, does 7 go into any of these? Any of these like kind of smaller numbers? 7 go into any of them? No, so I'm not going to stress about trying to figure out 7. However, 8 goes into 40 and 8 goes into 24, right? So 8 probably goes into what, or so, not probably, then 8 goes into 120. So 8 times what gives me 120? 15. That's why I did up there. Okay. Let's see. Looking at these, 9 does not go into any of these numbers, so I'm not going to stress about 9. But what about 10? 10 times what gives us 120? Oh my gosh, that was a lot to list out, right? While we were listing them out, did anybody notice a pair that can make a 14? 6 and 20. Now, here's what I'm going to say. If you're seeing you need to make this long list, well, right when you write 6 and 20, you notice you get what you want. You can stop the list there, okay? I can see that logic of you saying like, okay, I'm writing it down. I'm thinking and go, hey, here's my eureka moment. If I do 6 minus 20, that gives me negative 14. So I'm going to do 6 and negative 20. Now, both of these are going to reduce. What would 8 over 6 reduce to? 8 over 6, 4 over 3, because they're both divisible by 2. So that could be 4 over 3, and we'll check that in Desmos in a second. What about 8 over 20? What can that reduce to? Okay, 4 over 10 can still continue to reduce because they're actually both divisible by 4. So it actually reduces to 2 over -5. So you weren't wrong with how you were trying to reduce. We just need to go a step further. Again, I'm going to check this reducing because I know that's a little bit tougher for us. Not want to do that. So let's check here. Again, 8 over 6 reduces to 4/3. 8 over -20. Oh, that says -0.4. Oh, there we go. Hit the fraction. And now it's saying -2 over 5. So we did reduce those correctly. So that gives me a factored form. There's still 4 here. So 4x plus 3 times 2x minus 5. I know this was seemed a little bit long, and you're like, wow, this is really saving us time. It really is. Because if I was doing this without this structure to help me, like I said, I was starting with splitting up 8x or 8x squared as a 4x and a 2x, or an 8x and a 1x. Now I'm going to start testing different combinations that multiply to give me 15 or -15. So I really doubt the first one I'm going to try is a +3 with a 4 and a -5 with the 2, just because there's so many other combinations to try. I could have put the 5 here, 3 here. I could have tried a 1 and 15 combination. There are lots of different ways I could have gone with this. I could have thought that maybe 8x and 1x was the right way to go at first. And again, I'm trying there, not finding anything. So these are tough. I know this doesn't seem that streamlined, but it really is. So one more example here. Now this example is a little bit special. I have 4x squared plus 26x plus 42. Yep. Does anybody notice anything special about all 3 of those numbers? Yep. Anything interesting about 4, 26, and 42? Is there a number they're all divisible by? They're even, which means they're all divisible by 2. Since they're all divisible by 2, what I'm going to do is pull out a common factor of 2, and then I'm going to factor the rest. It's going to make my number smaller, because 4 times 42 is, what is that? 168. That's a big number to be working with if we don't have to be, right? So if I pull out this common factor of 2, now inside it becomes 2x squared. 26 divided by 2 is 13x, and 42 divided by 2 is 21. Elijah, this first. Go ahead, Elijah. Now, if I do 2 times 21, that's a much, much smaller number, right? So 2 and 21 multiply together to just give me 42. 2 and 2 here, and 13 at the bottom. Yep. So we'll look to see what multiplies to give us 42 in a second. Let's get the obvious answer out of the way. I know there's still a little bit of writing happening. What else can multiply to give me 42? Two times 21. What else? We'll have 3 times 14. I'm noticing 21 and 14 are both divisible by 7. So, oh yeah, 6 times 7 gets me 42. What pair can make a 13 here?
Make a what?
The 6 and 7, good. 2 over 6, can that reduce? Yeah, that would reduce to a 1 over 3, right? 2 over 7, just go say 2 over 7. So, see how this had this whole 2 that I pulled out in front? That's going to hang out in front. So what I'm going to do, these get rid of the same. X plus 3, 2x plus 7. And then this 2 from right here just hangs out in front of the whole thing. So we don't, no, remember, this is our final answer here. Yeah, you could multiply everything by 2 here. You would not be incorrect in doing so mathematically. However, if you do that, now you're starting to work back to here. Whereas this is the answer we want in the end with it all factored. So this one was a little tough. Let's double check ourselves here. So my first equation said 4x squared plus, what was that? 26x plus 42. And then I said my final answer was a 2 times x plus 3 times 2x plus 7. And there we go. We do get them to match up. If we have forgotten that 2 in front, we'll notice that the purple and the green are just not the same width. They look pretty close, but they're just not exactly the same. But once I put that 2 in front, there we go. So here with this, again, I'm not saying this is the easiest stuff in the world. Yes,